Hello, grade 8. This is Math 8, Unit 1, and Lesson 2. It's about squares and square roots. If we recall from last lesson, we learned that there is something called a perfect square, or square number, and that was simply if you take a number and multiply it by itself, you get a product here, and that product would be the perfect square of 5. In this case. So 25 is the perfect square of 5. Why? Because 5 times 5 is 25. And we learned that another way to write this would be to write it as 5, and we have this number up at the top, a small superscript we call it, that is an exponent, right? We learned that this is an exponent. And we pictorially represented this with a model here, that if we take one dimension and make it 5, and we multiply it by another 5, the amount of squares we'd get if we made these one-dimensional units of 5 this way and 5 this way and multiply them, we would get squared units, square units here, and we'd have 25 of them. So we know how to square a number now. We know how to square a number. But what we need to figure out how to do is how to do the opposite. So when we have a multiplication question like this, to do the opposite, we take our product and we put it out front as a 25, and then we can divide rather than multiply either of these numbers, and we end up at the end. So we can go 25, and let's take one of these 5s. The answer will be the other number here that we used to get the product. And we had some fancy words for these. The first one was dividend. So that's the number that's going to be divided. The divisor is what it gets divided by. And then our answer is called the quotient in a division question. And you might notice something here. When the divisor is equal to the quotient, so when these two are the same, our dividend is the perfect square. Okay? So when these are the same, the dividend is the perfect square. Let's do a little example here. I'm going to show you a couple ways to get to this idea here. What if our dividend is 16 and we want to divide by some number x that's going to equal that same number? One way we could do this is what we did before. I showed some students this, where we multiply both sides by this x. Okay, so for example, what if we multiply both sides by x? It would be the opposite of dividing, right? And we would be ending up with 16 on this side if we multiplied by x, and then this side would multiply by x, and we'd end up with x squared. Okay, now here we have x times itself is going to be 16, so we're still looking for that number times itself that's going to be 16. If this way is a little confusing, that's okay. I'm going to show another way. But there's actually a symbol that we can use that's actually kind of like another operation. It's kind of like adding, subtracting, multiplying, dividing. And that symbol is what's called the square root sign. So whatever we do to both sides, or one side, we also need to do the other. It's this little sign. It goes down and then up on an angle and then straight across. Whatever we do to one side, we have to do the other. And what the square root sign is simply the opposite of squaring it. So this sign is opposite. It's the opposite of an exponent. So here, when it's just like this, it's the opposite of a 2 exponent. So you have some variable here, whatever that variable is up at the top. To get rid of this here, we need to square root both sides. And I'll explain a little more what that means. This sign means to square root. So over here where I have this sign, it's square root of 16. We say the square root of 16. Now here, if we have the square root of x squared, these cancel out and we're left with just x. And then square root of 16, if we think about it, we need to figure out what number could make this by multiplying by itself, and that will get rid of this square root. So here we know that 4 times 4 is equal to 16. Those are the same numbers. When you get those same numbers, you can get rid of the root sign, and you end up with just one of those equals x. So what number would have worked here right at the start? When we had 16 divided by x equals x, well, it would have been 4, because 16 divided by 4 equals 4, right? So what is the square root of 16? The square root of 16 equals 4. I'll just write this in here. Square root of 16 equals 4. So to square something is the opposite of square rooting. These are opposites, just like adding and subtraction are opposites, multiplying and dividing are opposites, squaring and square rooting are opposites. Let me show this another way. If you have what's the square root of 16? Remember, that is the square root of 4 times 4, which is the square root of 4 squared, right? Because 4 times 4, when two numbers are multiplied by each other, 1 time, 2 times, that 2 becomes right there. This means the same thing as 4 times 4. So the square root of it is, this is 4, right? Because these cancel out, and we're left with it's 4. Another way to understand this is you could try to draw some squares or rectangles. Let's think about the factors of 16. We've got 1 times 16, right? And we've also got 2 times 8. And we've also got 4 times 4. That middle number, if it's a number that can be square rooted, it's going to be that middle number. Now let's think about it. Let's draw these. What if we did 1 times 16? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That is not, so that's 16 wide, that's 1 tall. That is not a square, so 1 and 16 aren't the square root of 16. What about if we made it 2 tall and go over 8? 2 by 8. Still not a square. What about if we tried, well, 3 doesn't work because 3 we'd have 1 remaining, right? But what if we do 4? What if we do 4 down and 4 across? We'd have 16 squares inside. 4 times 4 is 16 square units, right? So let's do some examples. First thing we might have, this is similar to question 5 in your assignment. Find the square root of 2. Well, that means, find the square of 2 is what I meant to say. Find the square of 2. That means to square it, which means to make it 2 to the 2, which you know means 2 times 2, which 2 times 2 is 4. What about 7? Finding the square of 7. 7, make it square. This equals 7 times 7. 7 times 7 is 49. What about this? We take the 11 squared. Remember to have it higher up. Don't have it down with the other numbers. That gets confusing. It would look like 112. This is the same thing as 11 times 11, which is 121. What about these? 6 squared. We need to find 6 squared. That's 6 times 6. And this is how you would show the work for your questions. 6 times 6 is 36. What about 12 squared? That's 12 times 12. 12 times 12 is 144. What about 0 squared? That's 0 times 0, which is 0. Let's do one more tricky one. What about negative 7 squared? Well, that's negative 7 times negative 7. Negative times a negative is a positive. 7 times 7 is 49. Notice something here, that the opposite numbers actually have the same squares. All right, now moving on to what we learned this lesson, we're going to take these and we're going to find some square roots. So if they say find the square root of 49, they mean the square root of 49. So we need to think what two numbers multiplied by each other would make 49? Well, 7 times 7 we know equals 49, so that means that the square root of 49 is 7. What about this here? Let's think of some factors of 9. What factors does 9 have? It has 1 times 9, and it also has 3 times 3. That middle number is probably the square. Think about it. 3 times 3. Yeah, it works, so this is 3. What about here? 1. What's the only factor for 1? Well, it's got to be the square root of 1 times 1. And what's that? It's just 1. Here's some more examples. Try to do it with me. Find the square of 1. So that means 1 squared, which means 1 times 1, which equals 1. Interesting. So 1 to the power of 2 means 1 squared. That means the same thing. What about this? This is 10 squared, which is equal to 10 times 10, which equals 100. What about this? This would be 100 squared, if we're finding the square of 100, which equals 100 times 100, which equals 10,000. Look at the pattern here. How many zeros were here? There were none, so there's none in the answer. How many zeros were here? 2, so there's 1, 2 in the answer. How many zeros here? 1, 2, 3, 4. How many in the answer? 1, 2, 3, 4. So looking at this more difficult one at the end here, this is going to be the same. What we're looking for here is, what is it? 3, 3, 1. So this is 10 million. One more. Times itself. Sorry, I ran out of room. There we go. 10 million times 10 million. How many zeros does 10 million have? 1, 2, 3, 4, 5, 6, 7. So it's going to need to have that many times 2, just like it had here. 1, 2 times 2 is there. That's how many zeros you have. So we need to have 14 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm going to take these numbers and go back the opposite way, okay? And how am I going to do that? So now maybe it says in your assignment, find the square root of the previous question's products or answers. So let's take this 1, and we're going to find the square root of it. Well, the square root of 1 is 1 times 1, which is 1, which is just what we started with. So we took that 1 and we turned it right back. I accidentally skipped a step here. 1 times 1 is the same thing as 1 squared, which is equal to 1. So it's just the opposite order. It went this step, this step, this step, this step, just in the opposite order. Okay. What about this one here? We're going to take our 100. We're going to find the square root of it, which is the same thing as square root of 10 times 10. 10 times 10 is 10, right? Square root of 10 squared. I meant to do this the whole way through. Oops. Square root of 10 squared is 10, which brings us right back to the beginning. This here, we had 10,000. The square root of 10,000 is the same thing as the square root of 100 times 100. So therefore, it is 100 squared that we have underneath. So this cancels out with that, and we end up with 100. I forgot to write this canceling out part. They're opposite. It's like when you add something and then take it away, or when you multiply by a number and then divide by that number, you always end up at that last number. Then here, okay, 14 zeros, right? 6, 7, 8, 9, 10, 11, 12, 13, 14. If we want to square root that, that would be the same thing as the square root of 7 zeros on this. 1, 2, 3, 4, 5, 6, 7 times 1, 2, 3, 4, 5, 6, 7, which is the square root of that number squared. 1, 2, 3, 4, 5, 6, 7 squared. My pencil's getting dull. Squared, which is that canceling with that, which leaves us with 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 zeros on there, which is that number we started with. So square rooting something is the opposite of squaring something. So if you take a number and you square it, to get it back to that number, you just need to square root it. Okay? So squaring that number brought us to 100, and then if you square root that 100, you'll get back to the number you started with. And the big point of this lesson is that squaring and square root are opposites.